Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving LeetCode 75 salt colors, the next question of our SDE sheet. So the question says, given an array nums with n objects colored red, white or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. We will use the integers 0, 1 and 2 to represent the color red, white and blue respectively. You must solve this problem without using the library sort function. So if you see the example 1, the nums array is given and 2 0 2 1 1 0, and if you sort it, it will give the answer. Similarly in the second example also. So the question is saying that we have to sort the nums array, and the nums array just contains 0 1 and 2. Okay, so now our brute force approach will be, we will just use the sort function. Okay, or if here is it written that the library sort function we cannot use, so we can implement any one of the sort functions, quick sort, merge sort, but they will take n log n time complexity. Okay, all right, so they will take n log n. Now our task is to optimize this. What we can do, we can see the elements are just 0 1 and 2. Can we count the number of zeros, count the number of ones, count the number of twos, and then this will take O of n time complexity in the first loop for counting the number of zeros, the number of ones and number of twos, and in the second in the second for loop, what we can do in the second iteration, we can just print first number of zeros, the number of ones, the number of twos. Okay, the printing one. Okay, so now this will be big O of 2 n time complexity, and this will be great because this is taking big O of 1 space also, better than big O of n log n. Now moving ahead, if we optimize this also from big O of 2n to big O of n, how we can do? So let's check what we can do. So we can there is an algorithm, I will tell you the name, but it's very obvious what we can do. If we sort it, suppose there are just three elements 0 1 and 2. After sorting it will become 0 1 2. Okay, all right, so now what we will do, we will move all the zeros to the left, all the zeros to the left side of the array, and all the twos we will move to the right end of the array, right side of the array. So, and there is only three kind of elements, 0 1 and 2. If we shift all the zeros to the left side, all the twos to the right side, then automatically one will be in the mid. So now how we will do this? Let's dry run from an example. The example is given 2 0 2 1 1 0. We will say our low is this, and we will say our high is this. We will take these two pointers, and now we will iterate using this I pointer, or we can see the mid pointer. Now, so if we start from the very first index, mid is equals to 0. If we find any 0, we will move to the left. If we find any 2, we will move to the right. This is our task, nothing else. So first we find 2, we have to move it to the last. we will swap 2 with high. Swap 2 with high, with the right end which is high. So we will swap 2 with high. Okay, now after swapping, this will become 2 and this will become 0. Okay, this will become 2 and this will become 0. Now uh, now we will not move mid now, because we have to check that for the edge case, suppose here comes 1. So if we move mid, we cannot uh, push 1 to its correct place. So we will not move mid when we are swapping 2 with high element. Okay, but in the low case we can move mid also. So in this case we will just decrement high. So let's say it's h, high is h. Now our mid is 0, and if it's 0, so what I said, that we will swap it with low, we will move to it to the left. So we will swap with this low. So after swapping, it will be in the same position because low and mid are at the same position. Now we will move mid also. Let's say this as m, mid is m, and we will move low also. So let's say this is L. Okay, so moving ahead, our mid is at now this position, this is 0. Again we will swap it with low. So after swapping it, it will be the same. Now again we will move ahead, and m will be, mid will be here, and we will also increment low. Now it's 2, we will swap it with high. So after swapping it with high, this will become 1 and this will become 2. So this will become 2, this will become 1. Now after swapping high, we will not move mid, but we have to move high. So high is also here. Now there is no we can say profit of moving mid now, because every one we can see is sorted. So we will take mid up to the high only. Okay, so this was the whole algorithm. Just the algorithm is just move all the 0's to the left, all the 2's to the right, using low and high pointer, nothing else. Now I will move to the implementation part. So first of all, we will declare the size of the nums array, nums.size. Now low pointer will be at the starting, high pointer will be at the end, and mid pointer for iterating to the whole array, this will be, we can say it's at the starting point obviously. And now mid is less than equal to high, because mid will start from 0 and go up to the last index, so high. This okay, so for now it will go to the last index, but we will not cross high. Okay, because there is no need, because we will see all the 2's are at the correct position, and after reaching mid is equals to high, the array will be sorted. We have seen through the dry run also. Now what I said, there will be only 3 cases, that nums of mid is equals to 0, or nums of mid is 1, or we can use, if else if also, we can use else if here and else here, so that we don't have to write it again and again. So if mid was 0, if the element was 0, we have to swap it with low. We will swap nums of mid with nums of low. Now our mid will also increase and low will also increase. Now moving ahead, if the element is 1, we will not do anything. We will not do anything. We have seen through dry run also. Now if the element is 2, we will swap the element nums of mid with nums of high, and high will be decremented. So this way our whole array will be sorted. Let's check the sample test cases. Unknown network error. Okay, let's check. Please check me. Let me check the Wi-Fi. Let me reload the page. Now if we check the sample test cases. Okay, wait. Let me log in first. I don't know how this has just log out me, but wait for a while. So it's correct because the main logic was just to move all the zeros to the left and all the twos to the right, and one will automatically be at the mid because there are only three elements. See, all the sample test cases are accepted. Now I have submitted it. Let's see if we are able to pass all the test cases. Yes, we are able to pass all the test cases. Now if I tell you the time complexity and space complexity, so the time complexity is we are using only one loop, so this is better than the count approach. So this is taking just one loop, and space complexity, yes, is big O of 1. Okay, so this was all for this problem. We have done it. So thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.